In section 3, we started with just systems of equations word problems. So y'all solve systems of equations with graphing, with elimination, with substitution. And all we're doing is taking those XY systems of linear equations and putting them into word problems. And so as you read through these, your first goal is to figure out what your variables are. And then you should see 2 equations come from those variables. So it says James and Gabriella each improved their yards by planting daylilies and shrubs. They bought their supplies from the same store. James spent $165 on 14 daylilies and 13 shrubs. Gabriella spent $66 on 7 daylilies and 1 shrub. Find the cost of 1 daylily and cost of 1 shrub. What are my 2 variables? The cost of the daylilies and the cost of the shrubs. So this is where we're getting our variables. Then they're going to have 2 equations based on those variables. If you see this first one, he spent $165 on 14 daylilies and 13 shrubs. In lieu of the word daylily and shrub, I'm going to put my variables. So I have 14, and instead of daylilies, I write X, and that's a plus. 13, instead of shrubs, I have Y. How much did all of that equal? That was the $165 that he spent. That's my first equation. My second equation says that Gabriella spent $66 on 7 daylilies and 1 shrub. So I'm going to say 7x plus 1y equals 66. Okay. I would solve by elimination here. Right? And so I would eliminate that x by multiplying that second equation by -2. All right. So I'm going to leave that first equation alone. I'm going to multiply everything by this -2, -14x, -1y, or -2y, sorry, -1, and -132. All right. Once I've done that, I can add down. My x's will eliminate. 13 and -2 give me 11. 165 and -132 give me 33. So how many shrubs do I have? 33 divided by that 11. I have 3 shrubs. Or not really 3 shrubs. I actually have $3 per shrub. How do I find out how much the daylilies cost? I just plug it in. So I'm going to take either equation, it doesn't matter. 7x plus 1 times 3 equals 66. Subtract your 3. Divide by that 7. How many daylilies do I have? Or not how many, sorry, how much does it cost? $9. And so that's my answer. My daylilies cost $9. My shrubs cost $3. So number 3 is a reverse digit one. So remember, when you have reverse digits, you have your tens place and your units place, okay? And so this says a certain 2-digit number. When you reverse the digits, you decrease its value by 45. What is the number if the sum of the digits is 13? And so your variables for a digits one is always going to be like a tens place and your ones place. I don't use an O there just because of the fact that it looks like a 0, okay? So you can use X and Y if you want to. It doesn't really matter. I'm going to start with this sum of the digits because that's the easier of the equations. So sum of the digits means that I just add those together. T plus U is going to be 13. That's the sum of my digits. The other equation is a little bit different. If I reverse the number, I decrease its value by 45. So I have to take its original value and subtract what happens when I reverse it, and I should get 45. All right? So how do I find the value? Well, the value of a number is its digit for the tens place multiplied by 10 plus the ones place just all by itself. That's the value of any two-digit number. So for example, I think the example I used was like 35. If I wanted to find the value of 35, I take the first digit, that's the 3, and multiply by 10 and add it to just the second digit, right? So I'm talking about the digits themselves that I'm trying to find. So that's all I've done. 10 times my 10 place plus my ones place. I'm going to subtract what happens when I reverse it. Well, if I were to reverse 35, I would have 53, which means I would multiply my units, my original units by 10 and add my tens place, right? That's what I've done when I've reversed my digits. So this second equation is just going to be switching those variables. I'm going to say, well, 10 times my units place plus my tens. I've flipped those. And that equals the 45. So that's how these are going to be set up. If you have a sum of the digits, you're just adding your two digits. If the value of the number is what you're talking about, you're going to multiply the tens place by 10, the units place by 1, pretty much. It stays the same. If you flip them, those variables just flip for that same equation. All right, so then I'm just going to simplify that second equation before I do anything else. I have a 10 times t plus my u. I'm going to distribute that negative. Minus 10u minus 1t. Combine my like terms. 10 and negative 1 give me a 9. 1 and negative 10 give me a negative 9. 45. How can I simplify that equation? What comes out of everything? A 9, right? So I can divide everything by 9. By the way, you can always simplify your equations before you start manipulating them with the other one. So I have t, that's a u, minus u equals 5. Right? So now I have two equations. I have this equation for my digits, and I have this equation for what I just calculated and simplified. So I'm going to take those two equations and do elimination. So I'm going to say, for this particular one, the first one, the t plus u equals 13, and the t minus u equals 5. This is already set up nicely for elimination, right? And so I'm going to use elimination. 1t and 2, right? 1 and 1. These cancel. 13 and 5 give me 18. So my tens place of my number is 9, right? So I know the first digit is going to be a 9. I can solve for my second digit by just plugging it into either one of these. If I have a 9 plus some number equals 13, what is my second digit there? Subtract your 9. My second digit is 4. So my answer here is 94. Does it work? Well, check it. If I add the digits, do I get 13? Yes, I do. So you can do a check of these just like anything else. If I add the digits, do I get 13? Yes. If I take the number, 94, and subtract the switch of that, 49, do I get what they told me I would get? Yes, I'm going to get that. Those both work. That's correct. When you have it in slope-intercept form, I would recommend you graph it that way. So in slope-intercept form, you start with your slope-intercept, which is this number that is being added or subtracted. Here, this is a -3. I'm going to go to my y-axis, and I'm going to plot the -3 on the y. My slope is -6. So my slope here, you can think of it as a -6 over +1 or a +6 over -1. Why do I do that? Because the top number moves me up and down. And on this particular graph, what happens if I were to try to go down 6? I go off the graph. So I'm going to choose to do it this way. Only one of your movements has to be negative for a negative slope. So instead of going down 6, I'm going to go up 6. But because that was up, my movement now needs to be negative, which is left. So it's going to put me over here. At this point, -1, +3. Once I have the 2 points, all I have to do to graph is to connect to those 2 points. And so I really just have to connect those 2 points and put the arrows on the end. Next one, I'm going to graph the same exact way. I'm going to start here at +2 on my y-axis. My slope is -1. Again, that's a -1 over a +1 or a +1 over a -1. I'm actually going to do the second one here as well. I'm going to go up 1 and left 1 because I can see exactly where they cross when I do that. If it doesn't work out that way, remember I said you can use the process of walking. By that I mean you can keep moving based on that slope until you figure out exactly where they cross. You're going to connect those. Your answer is where those 2 points cross. And so your answer here, your answer is where the 2 shadings cross. And so your answer is going to be depending on this greater than or less than. All right. The other thing we need to look at is this blue line. Oh, my dashing is a little too big. This blue line is dashed. And so you want to make sure that when you do this one, that you dash it. And so you want to make sure that you have a dashed line for that one and a solid line for the top one. Why am I doing dashed here and solid on the other one?
Because greater than equal to.
Right, so this one is just a less than, and this one is a less than or equal to. And so that's my graphing of my lines. It is identical to graphing just a regular equation. Now I need to figure out my shading. I figured out the solid and the dashed. These are both below. So if I go below this line, sometimes it's hard to tell what below is. So what I do is I look at my y-intercept. So I look at that y-intercept, which is right here on this red line, and I have to go below it. So which side of the line makes that go below it? Well, it's going to be this side of the line. The left side of the line is below it. Because here's my -3. -4 is on this side of the line. This is the side of the line that I would shade here. All right, and so if I were shading this one, I would lightly shade, obviously, this side of the line, right? Blue, we're going to look at the blue line. For this one, I'm at +2. Which side of this line is below 2? Well, it's this side of the line as well. And so I'm going to shade below that line. My answer is the combination of those, where they cross. And so the answer for this is going to be this wedge right here, where they cross. So this wedge is my answer. You can lightly shade. You can just try to figure out where the shading is and only shade that. Or you can shade in 2 different colors. But you need to make sure I know what your answer is on the graph for the shading piece of it. All right, when you graph in standard form, you can use your intercepts to do this, all right? So I am going to do the same thing I did before as far as graphing the lines, but I'm going to use my intercepts, my x and my y intercept to do this. And so remember, for this first line, my x-intercept is going to be that -6 over the number in front of x, which is 1. So that's -6. And I'm going to go to -6, which actually is off my graph here. They were not nice to do that. All right, and put it. I'll make sure that you do not have one that goes off the graph. My y-intercept is going to be that -6 over the number in front of my y, which is -2. So it's going to be at 3. Is this going to be a solid or a dashed line for this top one? Solid or dashed? Dashed. I know that because it is just less than. All right. I'm going to do the same thing with the second line. My x-intercept here is that 2 over the number in front of x, which is 1. So I'm going to go to the point 2. My y-intercept is going to be that 2 over the number in front of y, which is 2. So that's a positive 1. Is this one going to be solid or dashed? Solid. All right, so I am going to do a solid line there. Now I'm going to decide on my shading. When it is in standard form, you have to pay attention to what's in front of your y. All right, so in standard form, I have to now look at, this says less than, but look what's in front of your y. It's a negative. If I were to put this in slope-intercept form, I would have to divide by a negative, which would flip this sign, right? And so this particular sign, if I were to put it in slope-intercept form, would flip to greater than. So I am actually going to shade above this line. I'm going to shade above this line. All right, let's look at the next one. The next one has a positive in front of the y. So this would not flip. This would stay less than. All right, so this one doesn't flip. So we're going to do less than. We're going to keep it that way. Less than would be this side of the graph. All right, so when I look at where they cross, they're going to cross at this triangle right here. Wait, what did I do? Sorry about that. I wrote it in the wrong color. I wrote this in blue, and it made my brain want to shade this above the blue. So you can always change these to slope intercept. So if I were to take this top line, I can move the x over and divide by the -2. So moving the x over, dividing by the -2, that would flip the line. This would be a -1 over -2, so that's 1/2. A -6 over a -2, that's a 3. You would graph the same way, 3 and then up 1 over 2. You can see that this is the line, up 1 over 2. Same thing with the second line. I would subtract the x, divide by 2. Nothing would flip because I didn't divide by anything negative. This would be a -1 over a +2, and then it would be 2 over 2. And again, you can see I would start at 1 and go down 1 over 2. All right, so you can always convert it to slope intercept. Pay attention to dividing by your negatives, and pay attention to dividing everything by what's in front of the y, not just your slope. Everything gets divided. It says write an objective function and constraints for the word problems. Graph the constraints, answer the question that's asked. Okay, so when I grade these, I'm going to grade, do you have an objective function? Is it correct? Do you have your constraints? Are those correct? Did you graph correctly? And did you answer the question? All right, so these are 4-point questions when you have these word problems. They're worth 4 points. I'm telling you that because do not leave it blank. Don't leave it blank. That's a big chunk of a quiz if you leave a word problem blank, okay? You need to try it. So this is where your highlighters are your best friends, all right? And so we're going to read through the problem, and then we're going to go through and find our objective function. Your objective function is not necessarily always profit. A lot of times it is. Y'all had one with word problems and short answer, and you were trying to gain the most points. You have to think, what am I trying to maximize or minimize here, okay? So it says you own a small parking lot outside Yankee Stadium. You charge $25 a car. $25 a car and $100 per bus. Cars occupy 8 square meters and bus occupies 32 square meters. New York has a set limit of 50 vehicles in your 1,120 square meter parking lot. How many of each car and bus should you park to make the most profit, and what will your maximum profit be? All right, so we are going to look for everything. We are trying to maximize profit. And so the first thing we are going to do is we are going to look for anything that has to do with profit. So we'll go back through here and we will look and say, all right, I see something that has to do with profit. I charge $25 per car and $100 per bus. My profit equation also gives me my variables. And so I am going to apply a variable to each of those. I'm going to say X is for my car. Y is for the bus. And then I'm going to write a profit equation based on those two variables. 25 per car. Well, that's 25X. 100 per bus. That's going to be 100Y. And that's going to equal how much profit I get. I'm going to leave that alone for right now until I get my constraints and I graph them. So now I'm going to look for limitations. I have two limitations here. I have a limitation on space, and I have a limitation on the number of vehicles I'm allowed to have. All right? So we'll talk about space first. This is my first limitation, is how much space it occupies. All right? And so you can think of these constraints as limitations. Sometimes it'll be a quantity of something that you have available, or a number of hours that you have available, or something like that. You're going to look for something that is limited, and then go back and find anything that has to do with it. It says my parking lot is only so big, right? My parking lot is 1,120 square meters. That's a limitation. I can't put more space than what I have available. So I'm going to find that limitation and everything that has to do with it. Cars occupy 8 square meters. Buses occupy 32. And so my limitation here would say 8 times the number of cars plus 32 times the number of buses can be no more than what I have available, which is that 1,120. All right, the next limitation is based on what New York has set for me. The limit of 50 vehicles altogether. Limit of 50 vehicles altogether. So you'll notice I don't see anything else there, but this is actually just a straight variable problem. If I am adding up all my vehicles together, I'm going to add up all my X's and all my Y's. And the most that could be would be 50. All right. And so that's just, sometimes they will give you the most you can sell, like for the hot dogs and hamburgers from your homework. The most you can sell is 100. Well, that automatically indicated that if you added your hamburgers and your hot dogs, the most it could be would be 100. And so you'll see some that are like that as well. All right, so I am now going to graph these. The first thing I do before I even label my graph is I'm going to decide how big my terms are going to be by finding out what my intercepts are, okay? And so I am going to look at my intercepts for this first one. My x-intercept for that one is going to be 1,120 over 8, right? That number over my number in front of my x. And so I know I'm going to have a pretty big number here. So I am going to base my graph off of how big these numbers are, right? I'm going to look at my y-intercept. This one's 35. Again, we're not being exact here. I'm not going to say, did you do it exactly? But you want to go in between the third and the fourth hash there and mark that that's going to be your 35. And then I'm just going to connect those two. All right. I'm going to do the same thing with my second line. I'm going to go to 50. I'm going to mark that, and I'm going to go to 50 on the Y, and I'm going to mark that. And then I'm going to connect those two. All right. These are both shaded below, and so I'm going to do exactly what I did on the prior page. I'm going to figure out where they cross. It's going to be this wedge right here. And at this point, I'm going to try to figure out what I have as far as the intersection of those and as far as what my highest profit will be. So this is why I marked my intercepts, because my intercepts are going to be my vertices, right? So 2 of my intercepts are going to end up being vertices, which means that I have already marked them. I don't have to figure them out. I know this is going to be one of them, right? And I know this is going to be one of them. So I know I'm going to end up testing the 035, which is that red one there. and I'm going to test the 50, 0. The other one I need to test is this right here. All right, we don't want to assume what it is. We need to use some method to figure out exactly where it crosses. All right, and so I'm going to use like an elimination method or some other method to do this. And I'm going to show you really quickly what I would do with this particular one. So I'm going to take these two equations that I created,